All right, here's our quiz review for today. We're going to just do these numbers basically in order. Numbers 1 and 2 are pretty much the same problem. What I wanted you to notice in problems 1 and 2 was that the wording in the question seemed like it was asking for different information. Question 1 asked, how many roots does the graph have? Question 2 asked, how many zeros does the graph have? But those mean the same thing. Roots, zeros, solutions, x-intercepts, those are all the same. So it doesn't matter which word we use, we're referring to the same concept. Also, number 1 asked for the solutions. Number 2 asked for the roots. So all of this terminology means the same thing. So questions 1 and 2 were really just about terminology, making sure you understood that what we're asking for is our x-intercepts. That's what roots are. That's what solutions are. That's what zeros are. So in problem 1, this graph has 2 solutions, 2 roots, because the parabola crosses the x-axis at 2 different places. And those places happen to be -4 and 0. Literally everyone's paper that I saw today got this right. So I think everybody has a good understanding of this problem, as well as number 2. So for number 2, our graph crosses the x-axis at these 2 points. So we have 2 solutions, and they happen to be about, we're going to estimate, -4.6 and -1.7-ish. One student literally wrote ish on her paper. I loved it. When you're taking a quiz, you have multiple choice options. So you'll just select from the list of options which answer choices look the closest to what your eyes can estimate are the values. So we're not going to worry too much about getting these exact on our quiz review today. Number 3 said, a quadratic function has an axis of symmetry at x equals 3. Axis of symmetry at x equals 3. And it also has one of its roots at x equals 9. Answering this type of question might be easier if we can visualize it. So what I'm going to do is I'm going to come over to a graph and I'm going to actually try to draw what we just read. An axis of symmetry is a line that cuts my parabola in half. So if that's at 3, we have this line here at x equals 3, and this line should cut my parabola in half. This line should be exactly in the middle of my parabola. The other piece of information we're given in the problem is that we have a root at x equals 9. Since we know that the axis is right in the middle, and we can tell what the right-hand side has, we know immediately the left-hand side has to have it too. The axis of symmetry is a place where you know both of the sides of the axis have to be exactly the same. So if we have a root on the right that's 6 units away from the axis, we also have to have a root on the left that's 6 units away from the axis. So our second root would have to go right here in this spot at -3. So do you see the layers of logic we used here? First, we had to use our understanding of our axis of symmetry. Symmetry means mirror image. And then we had to figure out, if we know one side, what the other side would look like using that symmetry behavior. So our answer here is -3. I think everybody got number 4 right as I was walking around checking work. Number 4 is a pretty straightforward problem. We want to find the zeros, but remember, zeros just means roots. We want to find the roots of the quadratic function given by the table of values. So this table has x values and y values. Roots are the places where our y value is 0. So first, find the places where your y value is equal to 0. But that's not your root. That's the place where we find our root. But the root is actually the x value that's associated at that point. So our x values, our roots, are -2 and +3. And I'm pretty sure everybody got these right. I was impressed. -2, +3. We're going to use the same logic in number 5 that we used in number 3. We have a quadratic function, aka a parabola, with an axis of symmetry at x equals -2. So our axis of symmetry cuts right down through this vertical, this -2 vertical. So this axis of symmetry has to cut my parabola exactly down the middle. So the other information I'm given is that we have a root at x equals -5. And since I now know where the root on the left is located, I can easily find the root on the right. I know that my root has to be 3 units away from the axis. So I go to the other side, I count over 3 units, and I figure out that my root has to be at the location +1. And that's just symmetry coming into play. All right, number 6 is a calculator problem. So there's not really anything we have to write on our paper except for the answer. But I did notice that quite a few students had questions about their calculators today. A lot of your questions weren't your fault. So you picked up a calculator and somebody had messed with the settings, and so everything looked weird on your calculator and you needed some help getting it fixed. If that happens during the quiz tomorrow, get my attention. If you're looking at your calculator and something just seems off, just bring your calculator up to me. I could probably help you fix it. But one thing you should be able to do on your own is if you type your function in and you click the button graph and you want to see a picture of your graph and you don't see anything, start by trying to zoom. Click zoom standard. That'll change your window. And all of that is written on Monday's page of the packet. Underneath where it says using your calculator to draw a graph, the last step is press zoom to adjust your graph, try zoom standard. It says all of that right here. So don't forget, you have calculator instructions in your packet too. Use those if you forget what you're doing. All right, so now back to the question. On my calculator, I click y equals, and then on the first line, I type in our equation, 2x squared plus 6x minus 20, and then I click the button that says graph. And as long as your window was already reasonable, you won't have to do this, but if you need to fix your window, you will click zoom and then go to standard, and then go back to graph. And we can see from our picture, it looks like 1, 2, 3, 4, 5. It looks like our graph is crossing through -5 and +2. So all we have to do here is look at the picture, find those intersections, and those are our answers. Writing these backwards, -5 and +2. That's all you have to do. Pretty easy calculator problem. And that brings us to number 7. Number 7 looks like it's a word problem, but it's kind of not. It's really just a picture problem. Look at the picture, interpret the information. So the intro tells us that this graph shows the height of a rocket after it's launched into the air. Notice that the height is your y-axis and time is your x-axis. This is relevant. Okay, you need to notice these things because question 7a asks us about the height, whereas question 7b asks us about the time, and we need to be looking at the correct axis when we answer these questions. So 7a says, what is the maximum height in feet reached by the rocket? So the maximum is that point right at the top of the parabola. It's our vertex. So our maximum height is the height at this point. Since we're talking about height, are we going to use our y value or our x value? Can I get a volunteer? If I want the height, do I use y or x? Ben? Y, because our y value is height. This is probably the biggest mistake, second biggest mistake I saw on this problem was students using the x value instead of the y value. So I don't know if I drew that line perfectly straight. Probably not. But we're going to estimate that this is maybe 2,500 feet or 2,600 feet, somewhere in that ballpark. If you said 2,400, 2,500, 2,600, anything in there, you're good. On a quiz, you'll have answer choices, and you'll just pick the answer choice that's closest to what you think you can identify visually. The biggest mistake I saw in this problem was students forgetting to include your units. Don't forget your units. All right, on to our last question. The last question says, how many seconds does it take for the rocket to land back on the ground? So if we're talking about seconds, we're talking about time. So we're looking at the x-axis. Can somebody help me understand what moment we're talking about when we say the rocket lands back on the ground? So think in terms of height. As you shoot the rocket in the air, the rocket's going to have a certain height, but the moment that it lands on the ground, what is its height at that moment? 0. Thank you, Jenny. It would be 0 at the moment that it lands on the ground. So that would be right here, right? The height of 0 would be all the way down here on the x-axis. So we're looking for the moment when the rocket lands on the ground. That would be this point right here. We have another name for this point. Can anybody think of another name for this point? Anybody? We actually have 4 names for this point, and nobody can think of any of them. Jake? It's a 0. Jenny, do you have another thought? It's a root. Chrislyn? It's an x-intercept. It's a solution. Okay? This point here, remember what a root is. A root is the x value when the y value is 0. Well, this is certainly an x value where the y value is 0. We also call that an x-intercept. We call it a root. So question 7b is just asking you to find the root. That's it. And we're going to estimate that to be, I don't know, 25.2-ish. And don't forget your units. Seconds. And that's it. Everybody did really well on this problem. I think you guys all interpreted the graph really well. Don't worry too much if your estimates are a little off of my estimates. Remember, again, these will be multiple choice questions on your quiz tomorrow.